Good morning to one and all. My name is Sheikh Muhammad Iqbal, and today I'm going to give a seminar in finite automata theory about the introduction of finite automata, and I am from 3CSCD. So let's move to the seminar. So let us talk about the introduction to finite automata. What is finite automata? It is used for? Finite automata are used to recognize patterns. It takes a string of symbols as input and changes its state accordingly. When the desired symbol is found, then the transition occurs. At the time of transition, the automata can either move to the next state or stay in the same state. Finite automata have two states, accept state or reject state. When the input string is proceeded successfully and the automata reached its final state, then it will accept. Formal definition of FA. A finite automation is a collection of phi tuples Q, sigma, del, Q naught, comma F, where Q is the finite set of state and sigma is finite set of input symbol, Q naught is the initial state, F is the final state, and del is the transition function. Finite automata can be represented by input tape and finite control. What is input tape? Input tape. It is a linear tape having some number of cells. Each input symbol is placed in each cell. Finite control. The finite control decides the next stage on receiving the particular input from input tape. The tape reader reads the cells one from left to right at a time. Only one input symbol is read. Here is the diagrammatical representation of the finite automata. Here we have cells A, B, C, D, A, B, C, A, B, B, A in the input tape. And tape reader reading the input symbol, finite control controlling the flow of the input. It is the diagrammatical representation of the finite automata model. Types of automata. There are two types of finite automata. A DFA, deterministic finite automata. Second one, NFA, non-deterministic finite automata. Finite automata. Here we say it have two types: deterministic finite automata, non-deterministic finite automata. DFA refers to the dynamic finite automata. Deterministic refers to the uniqueness of the computation. In the DFA, the machine goes to one state only for a particular input character. DFA does not refer to the null move. NFA stands for non-deterministic finite automata. It is used to transmit any number of states for a particular input. It can accept the null moves. Some important points about DFA and NFA. Every DFA is NFA, but NFA is not DFA. There can be multiple final states in both NFA and DFA. DFA is used in lexical analysis in Q, which is represented by the circle. A transition diagram or state transition diagram is a directed graph which can be constructed as follows. This is a node for each state in Q, which is represented by the circle. There is a directed edge from node Q to node P labeled as a transition function of Q comma A is equals to P. In the start state, there is an arrow with no source. Accepting states or final states are indicating by a double circle. Some notations that are used in the transition diagram are Q1, state transition from one state to another. And here we indicate start state using the arrow symbol indicating to the Q0. There is a description of how a DFA operates. In DFA, the input to the automata can be any string. Now put a pointer to the start state Q and read the input string W from left to right and move the pointer according to the transition function. We can read one symbol at a time. If next symbol of the string W is a pointer is one step P, move the pointer to the transition function of P comma A. When the end of the input string W is encountered, then the pointer is on some state F. Second one, the string W is said to be accepted by the DFA. If R belongs to F, that means the input string W is processed successfully and the automata reached its final state. The string is said to be rejected by DFA if R does not belong to F. Example 1. DFA with values with input symbol 0, 1 accepts all strings starting with 1. the input string W is processed successfully and the automata reached its final state. The string is said to be rejected by DFA. The finite automata can be represented using a transition graph. In the above diagram, the machine initially is in start state Q0. Then on receiving the input 1, the machine changes its state to Q1. From Q0 on receiving 0, the machine changes its state to Q2, which is dead state. From Q1 on receiving input 0, 1, the machine changes its states to Q1, which is final state. The possible input string that can generated are 1011, 110, 101, so on. That means all strings starts with 1. Example 2. An NFA with input states 0, 1 accepts all strings starting with 1. The NFA can be represented using a transition graph. In the above diagram, the machine initially in start state Q0. Then on receiving input 1, the machine changes its states to Q1. From Q1 on receiving the input 0, 1, the machine changes its states to Q1. The possible input string that can be generated is 1011 and so on. That means all strings starts with 1. So let us discuss about the transition table. Transition table is basically a table representation of transition function. It takes two arguments, a state and a symbol, and returns a state, the next state. The transition table is represented by the following things. Columns corresponded to input symbol, rows corresponded to states, entries corresponded to the next state. The start state is denoted by an arrow with no source. The accept state is denoted by a star. Here is an example for an DFA. Transition table of DFA is as follows. From Q0, by giving the input 0, it is moving to Q1. From Q0, by giving the input 1, it is moving to the Q2. In Q1 state, by giving the input 0, it is again moving to the Q0. In Q1, giving 1 as an input string, it moves to the Q2, final state. In the final state Q2, 0, 1, that takes both input string 0, 1 and moves to the same state Q2. In the above table, the first column indicates that the current state under column 0 and 1, the next states are shown. The first row of the transition and on one input, the next state will be Q2. The third row, when the current state is Q2, on input 0, the next state will be Q2, and on one input, the next state will be Q2. The arrow marked to Q0 indicates that it is a start state, and a circle marked to Q2 indicates that it is a final state. Let us take another example about the transition table. Here we have given a DFA, NFA. So let us build the transition table. The transition table of a given NFA is as follows. The first row of the transition table can be read as when the current state is Q0 on input 0, the next state will be Q0, and on input 1, the next state will be Q1. In the second row, when the current state is Q1 on input 0, the next state will be either Q1 or Q2, and on one input, the next state will be Q2. In the third row, when the current state is Q2 on input 0, then the next state will be Q1, and on one input, the next table will be Q3. In the fourth row, when the current state is Q3 on input 0, then the next state will be Q2, and on one input, the next state will be Q2. Thanking you for giving me this opportunity.